Alright, so my name is Bill, and this is my video on the GDC video, Fortnite's Real-Time Lighting Techniques and Tools by Epic Games at GDC 2018. This was a 20-minute talk given by Zach Parrish, the Senior Dev Real Tech Artist at Epic Games, and he describes a whole bunch of challenges as well as techniques that Fortnite uses in the Unreal Engine to be more efficient with lighting and with shadowing and other graphics techniques such as that. So first he goes and lists a couple of challenges in Fortnite lighting, which is that since it's a massive world with when just about every building or placed object is destructible, it's nearly impossible to have a pre-baked shadow map or a static way to do shadows beforehand. So pretty much everything, lighting and shadows, has to be done in real time as the game is played and as things in the environment change. So the main major tool that he talks about is called mesh distance fields, which was a fairly new Unreal Engine feature that Epic Games coined with Fortnite. And it's essentially for each object in the game there is a 3D volumetric texture, and that will it'll store distance values from the object itself. And there'll be multiple layers. So perhaps at right on the mesh, you'll have a distance of 0. You'll have a small aura around the mesh with a distance of 1 or 2, and I think it goes up to 5 pixels away, or 5 units rather, away from the mesh, and this is done for every object in the game. And so then, since it's a texture, so therefore this doesn't consume any CPU cost, but it does consume a bit of additional memory for each object. The distance fields are then used for techniques such as ambient occlusion and shadows. For shadows in Fortnite, they're done by ray tracing from the distance field, from the light source to the distance field. And since the distance field is just a 3D texture of stored distances for each pixel, based on how high of a resolution the distance field mesh is, you can use the mesh itself to generate shadows instead of the hard object itself. So it's a good way to make soft shadows, which doesn't consume as much memory. And but it is a bit more memory expensive. So at a far distance, Fortnite will still use at a close distance, Fortnite will still use dynamic shadows because these mesh distance field shadows are static and won't be able to be animated. So where you want things like moving trees or other animated objects, they'd still use dynamic shadows, but these shadows can be blended with the DF shadows at a farther distance where the player won't notice as much to save memory. And the distance field also determines how ambient occlusion works. So since it calculates the distance between objects, so it'll also be factored into the algorithm in which ambient occlusion is then calculated. And Zach didn't go too far into how ambient occlusion directly works in Fortnite or the algorithm itself. So all he really said was that the distance fields are used in the calculation, but not really how. Capsule shadows were also used. He explained that capsule shadows are pretty much for each object you convert it into a series of into a circular rig that's just a bunch of blobs, and you use these to render shadows instead for much simpler geometry. And essentially what you get is a much softer looking and much simpler shadow that can save a lot of memory. He also mentioned dynamic light culling, which is essentially what we did in assignment 2 for dynamic light volumes, which is where lights only exist within a certain area, and once the viewer is outside that area, that light is no longer affecting anything the viewer sees. So it can also be set to fade out after a set distance. So that instead of an abrupt looking like a light turning off, it'll look more like the light fading out, and it might not be as jarring to the viewer. And lastly, he quickly mentioned dynamic shadow caching, which is that shadows, like if two objects, like a light and an object that are moving, then the shadows between them won't change. So since shadows are, so that calculation can be just cached instead of calculated fully with each call, and that will save a lot of memory. The example he gave with 3 lights, on the first call, its full cost was 14.89 milliseconds, and subsequently it dropped to 0.9 milliseconds, which is quite a difference in saving memory. And that's my video. Thank you for watching.